Hello.
Hi. All right, everyone. Welcome to SCR's 2021-2022 General Meeting of August 3rd, 2021. As you can see, I'm using a very nice mic just because I want better audio quality for the recording. So if you're listening, I hope it sounds good. So first on the agenda, uh, we have a few things we're going to talk about. Again, weekly shout outs. That's every week now. Sub-team updates, Google Drive, ClickUp, recruiting. And then at the very end, if you have any questions, feel free to ask. But first, we're going to bring this up again.
Yeah. So just a quick reminder, if you guys missed the last meeting, we talked about some important stuff, as you can see on this slide. I'll reiterate it just because you know, it it still hasn't been solved. But there was a graphics card that was found missing in the lab. Well, not found, but it's missing in the lab, and it belongs to the Dr. Corner, who is doing research in the back room in the lab, and she noticed that the graphics card is missing. And so uh, Dr. Hungerford, the owner of the lab, and Dr. Corner spoke to AIAA with concerns that it might have been us. If it is found to be us who or anybody on the team who stole it, there are some very serious consequences. So the team can be shut down completely, or even the entire organization, AIAA, including the different project teams, so hobby rocketry, space city rocketry, and UAV. Everybody can get shut down if that's not found. So we really, really, really need to find it. If it was any of us, we need, we really want everybody's cooperation. So you saw anything, you heard anything, it's important that you speak up. Quick things that we're going to change with the lab, and like I guess our policy with the lab is number one, we will be requiring everybody to check in and out when you go to the lab. We will be changing the key code to the lab. So I know a couple people have access to that code. So we will be changing that to where it's just the sub team leads, Urban and I, and then JP, the president, sorry, Omar, the president, and JP, the program manager. So just those people are going to know. So it's limited into who has access to the lab. Second thing with the whole access to the lab thing is you have to have either a lead or Irvin and I, or JP and Omar for that matter. So just those people who have access to the key, only those people will. You have to have those people with you to be in the lab. If they're not there, you are not allowed to be in the lab. And so those are quick things for the update with the lab. Just one more thing: the back room was also discussed to be locked, so they will be changing the key to that back room. So we still potentially can use it for storage, but it won't be as accessible to us. We'll have to be asking anybody, I guess either Dr. Corner or Dr. Hungerford, to open that for us if we want to access anything from back there. And I guess just if anybody has questions about the situation, now would be the time to ask. Okay, I guess not.
No questions.
We'll move on.
We'll move on to shout outs. Again, first off, I want to shout out Structures. We want to shout out Structures for meeting at the lab and getting to learn how to use the X-Winder. So first, thank you, Haley, the Structures lead, for being there and showing everyone how to use it. And of course, Ravi, the X Structures lead, now leading analysis, helping them out throughout the whole process. And then new members, Mitch and Evan, showing up and getting some work done, being able to use the X-Winder and being at the lab for a very long time. I know they all woke up early to get there. And then also shout out to Carlos for having an actual very, 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 very good idea, a very good design for a high altitude black powder separation system. There was a lot of technical questions being asked. He brought up a lot of technical ideas into his meeting, and hopefully the rest of the recovery members are going to be presenting more as the weeks go by. And then lastly, Ozzy, for having his first meeting for the SR propulsion this year. It was great. We had a lot of fun talking about the hybrid motor. And then yesterday we met with the capstone team, and when we discussed a lot of what's going to happen this fall semester, as that's their second semester in capstone. Sub team updates now. They're going to be a little more different, and you'll see why now. So this is the order we're going to go in. And each sub team is going to have a slide that has some visuals and some things that they want to discuss. So first up, Ozzy with S-Trap Propulsion.
Yep. Thanks, Irvin. First of all, I'd like to say thank you. What's it called? So much for being here. To over exaggerating. But no, I apologize for being gone for so long. I was unaware that we were gonna be what's it called? Literally in the middle of nowhere for an entire month. So now that I'm back, I'm trying to get everything back started. And so we actually do have a lot of updates. Of course, Irvin already mentioned that we had our first SRAD propulsion meeting, in which we mainly talked about just updates and the scope of our work for the upcoming year. Because there's so much stuff to research and go over, we mainly focused on our upcoming meeting with the capstone team, as well as trying to just get everything settled down with how our templates for our documentation are going to go. The meeting with the capstone team was actually I personally think it was a great success. I think we're going to have a great time working together. So we learned that there's been a couple of minor changes to their project as to the capstone project. First of all, they're limiting their scope of work in order to complete it before the end of the semester. They will work closely with us to focus mainly on the design and fabrication and testing of their flow control system, which includes the valves and all the controllers and computerized system for that, the injector plate, and of course, a lot of testing close to the end of the semester using pressurized water. I'm hoping that we can use the current test stand. It looks like we will. The current test stand will be used to perform those tests since there's not many high forces involved. It's a very good base to mount stuff to test that kind of stuff. So I think that'd be a great use of that test stand. We also determined that they are planning on using, or we're doing their math for the solid propellant using aluminum loaded paraffin wax as their solid propellant. And of course, just that the capstone team is going to be working closely with us, specifically with the SRAD propulsion team, and will hopefully work with us in the lab as well. So I know the SRAD propulsion team is going to be very familiar with the team members of Andrew's and Christian's capstone team. But if you guys see them, say hi to them. They are previous members from either AIAA or Space City Rocketry. So, it's great to work with them, and it'll really hopefully put us ahead and into what I think is the future of Space City Rocketry. So, and lastly, we are finalizing our document for the safety and design review. It's just a overarching document that takes into consideration all of the design and safety aspects for the project in the coming years. So we're working to finish that, but that's it for me. Thanks,
Thank you,
guys.
Ozzy. That's great. Next up is avionics. Unfortunately, V.
I actually just made it. I'm sorry. I ran late, but I'm here. I literally just got on.
Okay, go ahead.
Sorry about that for being late. So for avionics, we ended up creating different subsystems for avionics so that everyone is able to focus on different areas to be able to be a little bit more specialized on some of the different tasks that we have to do this year, as well as ensuring the progress and creation of everything that we have to do, stay on top of things. We had our meeting, and we're going to start meeting in person. I want to talk with everyone just kind of briefly and let everyone know kind of what they're going to be doing and, which team they're more interested, which subsystem they're more interested in working on, just so we can get that all sorted out.
All right. Thank you, V. Next up, recovery.
Hey guys, thank you for the weekly shout out. Those always make me really happy, and I really don't mind if you guys keep giving them to me. So wink wink, just always give them to me, please. Anyways, recovery this week. So we assigned specifications among the sub team members. So every recovery member now has something to focus more on. Then we also went over an example of a proposed design for Zenith. This was my idea. I'm not going to go into it for this meeting, but the slides are on the drive, and I'm not sure if the actual recording has been posted, but the recording is saved on my computer, and I also emailed it to Irvin. So you guys can find the link probably later on this week. But yes, we went over this design here. It works using black powder, and it's pretty similar to Oberon system. It's just really long canisters to make sure that the black powder burns evenly, even at high altitudes. Like I said, there's way more detail in last week's meeting. So recovery will also be reaching out to other sub teams to discuss likely or desired requirements from other sub teams. And we also had a quick lesson on how black powder works this week. So if you want to learn more about that, it's also on the meeting.
Thank you. I will be posting this recording and also recovery's recording today on the AIAA YouTube channel. But thank you very much. Next up, structures. Haley.
So this week on, let's see, last Saturday was whenever we met and did the test wind. So appreciation to everyone who came out for that. We'll be doing documentation shortly to so anyone going through it for the first time can pretty much go through that and understand how to do it, understand all the interworkings of everything. As mentioned in the chat, we will most likely be going for another tug of war with the car and a post, unless we come up with something new to get it off the mandrel. And then these are our two designs that we have going currently for modular fin canister to be external, because obviously the minimum diameter rocket. And this cute little video right here is our time lapse that we took.
Let me see if I can play it. Oh, can y'all see it?
Yeah.
Very nice.
Yeah, that's it for this week.
Thank you, Haley. Great work this weekend. Ooh. And then COTS propulsion, Tala.
All right, so this week we came up with a new way that we're gonna choose the long list for our potential motors. We usually started by choosing class first and then the specific motor, but this time we're gonna do just like a giant list of potential motors, group those into like my class, pick the best one out of the class, and then compare the best from each to each other. I think this way, and the team agreed, we won't be leaving out a motor accidentally. So this way we kind of give them all their fair shots. Also, we got our first assignment this week. We currently have 6 motors that we are considering, but every sub-team member should, at a minimum, have 2 ready to present for this week. So we should have a solid long list of potential motors by the end of the week, if all goes according to plan. Yeah.
Thank you, Tala. And then next up, the man himself, Ravi, with analysis.
Right. So analysis had kind of a slow week, to be honest, didn't do too much. But in the last week's meeting, I assigned our first task, kind of similar to other sub teams. We have, or I've uploaded the compression data from last year's structures team, who completed the testing on the custom wound or the X winder wound fiberglass tubes. You can see a picture in the bottom right. So I've kind of assigned Omar and Amy to start looking at that, be in communication with Haley and structures as to what we want to get out of that data so we can start analyzing that. We also have our open rocket kind of mini project competition thing due in this week's meeting, just seeing who can get the closest to 30K to try and, I guess, give members more experience using open rocket, kind of the nooks and crannies of learning a new software. And then also a very exciting development is I'm going to be having a meeting with Andrew and Fani tomorrow night, just about FEA and more broadly how we want to use it for the team and our major goals with that, and how we start, I guess, familiarizing ourselves with the process and the software that we're going to be using. So reaching out to him for advice, and then also staying in contact with the RISE team, seeing what they think. Yeah, this meeting will also have a mini kind of lesson on FEA and CFD, just so we can start to really understand what we want out of it, what they are, and how it can benefit the team moving forward.
Just a quick question, Ravi. If possible, I'd love to join that meeting with you.
With the, like, Andrew or the sub?
Yeah, no, with Andrew. Yeah.
Right. Yeah, sure.
Thank you, Ravi. Now let's look at some of what I was talking about, the Google Drive. So I think we have pretty much done the best we could as far as organizing the Google Drive for the sub teams. So the way you get to the Google Drive for SCR is first you need to have a link, and then one thing I suggest is whenever you have a link to either your sub team or the SCR like whole folder, is to favorite it. That way you don't lose it. And I know on your left hand side you have all your favorites, and that way you can always find it there very quickly. Or you can also favorite in your browser. That way, you know, you can find it. And then how do you get to the sub teams from there is you just go to Zenith, you click on that folder, and then you'll see another folder inside of that. That's the sub teams. And that's where you will see the sub teams on right there, all of analysis, and then also a folder for document templates. For some reason, I thought that if I change the colors in my computer, it would change them for everyone else. That is not the case. So I guess it's up to you to change them how you want. And then once you click on any specific sub team, you will see pretty much the same organization, like folders. Like every single sub team will have a CAD files folder, a media folder, and so on. And I know, as Carlos and Ravi mentioned, they have the presentations in there. The sub team leads have already started, I guess, adding stuff. I think I don't remember who asked me about a source, and if you have anything you want to contribute to learn for the sub team, you can add it on sources, and it's pretty much self-explanatory as to what goes where. And I guess for sub team leads, if you want to add something or you want to change it, you are welcome to. This is just to get y'all started for organizing. Just make sure that it stays organized and nothing's just floating around. There's even a unsorted folder in there, just in case you don't know where to put it. But yeah, the Google Drive is up and running. Next up, ClickUp.
Yep. So ClickUp is a, you know, like a project management or like a task manager for big teams. Irvin, if you could go to the next slide, please.
Sorry.
No, you're good. So Irvin and I have been looking at ClickUp because we want to really implement something to organize ourselves and really make ourselves an effective team and be able to see the project as a whole as time goes through. And we really think ClickUp is going to be the right way to do that. And right now, for the time being, Irvin and I are working with all the sub-team leads. We'll be meeting with them throughout the week to try to get a roadmap kind of built for how the semester is going to go, what the work's going to look like, any real milestones that we need done, and when we need them done by. And then Irvin and I asked that all the sub-team leads in your weekly meetings or whatnot, meet with your members and try to fill out those tasks that need to get done. That way, we have a bigger understanding, or like a more complete understanding of all the work that needs to be done, when it needs to be done by, how long those processes are going to take, and so on and so forth. That way, like any member who I guess needs to step away for whatever amount of time for schoolwork or whatever, can come back and really just look at it and know where things are going with the project. With Caleb's permission, we want to have some implementation or integration with Discord, and we're gonna wait around 2 weeks for that. So just, I guess, the rest of the week to meet with the sub team leads, and an additional week just so you guys can meet with your sub teams or within your sub teams to get more stuff added to that. And once that's done, we will try to integrate it with Discord, so that way it's all set up. It'll give you reminders if things are getting close to a due date, if things are late, when tasks are added or who they're assigned to. So that's all good stuff. And yeah, we plan to have that done in around 2 weeks from now. Here is a little preview of what it looks like. So Irvin and I actually met with Haley last night, and we worked on, just some basic, I guess, tasks and things to work on. And so this is just a little preview of what it's going to look like. Your guys's might look very different, and once you guys work with your sub teams or within your sub teams to get more tasks added and milestones, it'll look a little fuller and more complete. But this is just a little preview, so that's really cool.
Yeah. Also, like there's like as Goose mentioned with Discord, you can integrate it and do have like automations and a bunch of notifications. So if something's late or a comment was added on a task, it will notify you on Discord and tell you what's happening with the team. And you can do it for specific sub team too. So you will only get it where it should be going to.
A quick note on recruitment. If you want to go to the next slide, Irvin, for me. Thank you. Irvin and I have been meeting with new members or new prospective members for a little bit now over the summer. Thank you guys for suggesting your friends and people who are interested. So far, we've met with 10 people, and they've been added to sub teams and the team in general. So I think that's really cool. There's still like 4 to 5 people that we need to meet with, that we have interviews scheduled with. So I think that's amazing. It's really good to have members here. And right now, though, we think that there's enough members for each of the sub teams to get some good foundational work. So that's really good. But we want to, I guess, put a hold on it because, just so we can start really focusing on getting some work done before classes start, and getting everybody integrated. And then once the semester starts up for the fall, we will get together a proper application process with a whole form and everything. That way it's a little more organized, and that'll be coming around in the fall. So if there's anybody who who's still interested, it's not, the team's not closed or anything. We will be adding more members later on, but just for the rest of the summer, we'll be holding off on adding any new members. And I guess that opens us up to questions.
Yeah, and by the way, the rest of the summer is just 3 weeks.
I know it's not all that long, but still.
Yeah, questions?
Yes, Celine, we do have access to the drive. If you didn't get it, we did send it a while ago on Discord, but I can send it again on here, and
We can send it to every sub team if we can right now.
yeah, I'll do that.
I'm gonna stop sharing my screen, but again, questions right now. No questions. Nobody has a question.
That's crazy.
Dang.
Y'all know everything. It's really good, actually.
You guys just present so well. Here's the questions.
Thank you.
Yeah, my,
Ravi.
my question is how we get so lucky to have, such great leaders for
You're making me blush right now. Let me see. I have a question. Structures. Any new designs for the modular FinCan?
we're working on it.
Okay. Cool.
We did just get 3 new members, with Evan, Mitch, and now Donald. So hopefully
Mhm.
we got some new people with some new ideas and they'll they'll get working with us. But meetings have been a bit light on attendance. So
It'll pick up. I'll pick up. Same with analysis. Honestly, soon as we get like an actual idea of what FinCan design we're gonna be using, I think analysis is gonna have a lot of work to do on that. So they'll keep working, and also I feel like SR proportion might need analysis help. So analysis, y'all be ready, Ravi.
Yeah, it'll pick up for sure.
Okay, well, I guess nobody has any questions, right?
Hey, real quick, analysis is supposed to do all the math, right?
Not all the math, but I
Oh,
guess a
whoa,
good
whoa,
portion
whoa,
of
whoa,
it.
whoa, whoa.
I got a couple pages.
They're supposed to kind of help out, but we can't. You can't make him do everything.
That's fair.
So I actually have a question for you guys. So, avionics is planning on implementing, being able to implement different sensors for, like kind of in a modular way, such that we can launch one time with one set of sensors that we might want, and launch another time with a different set of sensors that might help us determine different bits of information. And so with that in mind, I was wondering what kind of sensors would the different sub-teams like to see? Like, what would you guys be interested in? I know one of the things that was talked about quite a bit last year for analysis was getting potentially strain gauge sensors on the fins, which is something I imagine structures would still enjoy. I think I talked briefly with analysis and asked them, but I want to pitch it to everybody here. What kind of information would you guys like to see picked up on the rocket?
Thermocouples throughout the rocket, but you gotta find a way to put them in the rocket.
What parts of the rocket though? Like
the motor casing, but you gotta find a way to put in because it's a minimum diameter rocket.
I mean,
So,
thermocouplers are like a couple millimeters.
They're pretty thin. It's just having holes to, I guess, go all the way down to the motor.
You can have like pad. You can have thermal pads instead of a thermocoupler.
That too.
I guess the concern is like it's gonna be a snug fit between the motor and the airframe. It's not like there's no wiggle room. The motor tube is the airframe.
That's what I'm saying. Thermal pads. Think of it like a piece of tape that is a thermocoupler.
Okay, what about the wiring for it?
It has wires that stick out of it, but it's, for the most part, it's completely flat. And then there's just 2 wires that extrude out of it at the
so
base.
are you sure they would fit a minimum diameter?
Right. Yeah, because we're saying snug. Like you might shear.
We're
those
talking,
wires.
I mean, you can get some of these, depending how much you want to pay, you can get some of these as thin as like 0.2 millimeters thick.
Like the cables are that thick too?
The cables come at the bottom, right? So we would have such that the actual pad is touching there, and then the cables are above the actual motor, if that makes any sense. The cables come off of the sensor, and the sensor would be directly on the motor casing. and the cables would come up on top of the motor casing.
How's Nug are you talking, Gus?
Say what?
How's Nug? Is the motor to the
Like
outer frame?
I can't say for sure right now because we don't know the dimensions on the airframe that's going to be built. But ideally, I would say as snug as you can get it because you want to minimize vibrations on that motor.
Yeah, I can see that. Okay.
So
Yeah,
so
that may
V,
be something. Is that like a set in stone, like for the design of it? Is it going to be like snug as it can be, or is there any way we can work around it to maybe increase the diameter, or I don't know. I know that's like a huge
It's
thing.
not,
So
yeah, it's not impossible to increase the diameter. Like that is still an option, but I guess I would lean on the side of maintaining the diameter as small as possible, just because, you know, cross-sectional area is one of the bigger things that produce drag. So if you can really reduce that cross-sectional area, so I guess like the top-down view of the rocket,
yep.
the easier it is to get to 30,000 feet. So
Yeah,
the
totally.
snugger, yeah, the snugger we can get it, the better, honestly. But it can increase if need be. Just better if not, if we can find a solution
Yeah,
around
I
that.
mean, as you were saying, we could definitely find a solution if the space is still there. You know, like if it's really snug as it can be, as in like us putting in like the avionics bay or you know the payload bay into Oberon, like that snug, then there's I believe there's probably no way for us to actually fit thermocouples there. But yeah, I don't know. We'll definitely have to look into that.
Yeah.
If we do go down the line of trying thermocouples, because that would be difficult in how I see it, at least.
One thing I could potentially just brainstorm and spitball would be getting like a router and cutting a slot for cables down the side of the airframe. And the airframe shouldn't be too thick, so that'd be a problem, but you could always reinforce that section on the outside with a fiberglass patching. That is an option. So once you route it, you know, you reinforce it.
So instead
But
of it being on the inside, it would be like on the outside, and somehow through the airframe, allowing the thermocouples to access the motor.
you could do it through the outside, but I was thinking like you could get like a maybe like a half-inch thick section and have that cut in, like I guess outwards from the inside into the airframe. I guess like a millimeter, not even a millimeter, like half a millimeter in, and they just route like get that section to go all the way down. That'd be a little more complex to like pull off, but I guess it could be done.
I see.
Or when you wind it, I guess you could put like a little pad or something that is, I guess, a half-inch thick and a half a millimeter tall, like a shim
So
or something, and wind on top of that.
Mm-hmm.
I attached an image in the general chat on Discord just to kind of give an idea. It's not quite as thin, and what I'm thinking of the silicone ones. This is obviously not silicone.
that looks like a
but-
very thick thing.
Yeah, no, I would go with a silicone model, right? The silicone models are a lot more expensive. This is one of the welding models. This is used for welding. It's for a lot higher temperatures and a lot thicker intentionally. But the idea is it's kind of shaped like that, but it's made of silicone. So it can go down to like really thin size. And we would be able to, you see how the wires are kind of extruding from there? On these pads, the wires go off the side. So it comes off like the top or the bottom directly, not like the top face or bottom face, but like, you know, sides of a triangle, sides of a square, excuse me, type B. And so with that in mind, oh fuck, sorry, I'm driving. With that in mind, I was thinking that we can put it towards the top of the motor casing, so we can still read temperatures off of the motor casing, but the wires go above, so it's not in the way of the actual, you know, in between the thermal casing and the airframe. I guess we don't. Basically, it's going to be the size of the airframe. So yeah, I guess that was kind of an idea there.
Didn't
Okay.
last year, didn't we have the idea of putting thermocouples on multiple like positions along the motor casing?
Yeah,
Yeah, I think someone talked about a thermal gradient.
Mm-hmm. Yeah, that was the initial plan, was to get a gradient out of the, like a temperature gradient out of the motor. But after looking into that concept, it is quite hard to get like a precise gradient of a spherical object like that, or cylindrical, my bad. But yeah, you know what I mean. Like it's if you're talking about thermocouples, you're only measuring really the true temperature at that exact contact. So if
Yeah.
you're trying to get like something that's round, you have to go around that whole like round object, maybe multiple times, you know, maybe, I don't know, 4 times, depending on how accurate you want to be. But yeah, that would also, yeah, I mean, we need more space for wires. That means we'll need more space for multiplexers to connect all those sensors together to be able to be read simultaneously. So yeah, there's some complication into that, but
Yeah.
with 3, we can at least create like top, bottom, middle temperature kind of the motor for us to start testing that idea.
Well, I can say that if that's something you are confident that you can pull off with additional space, I guess my question would be, how much space do you need? And then work with propulsion and structures to see what it would look like to increase the diameter to that size, and how much more, I guess, energy we'd need to get up to the top, to the 30K target.
Mhm.
See if that's feasible.
Awesome. That, yeah. Yeah, I think it would be really cool for us to have those thermocouples on there. I'll definitely get in contact, propulsion, Haley, and everybody.
And if you're increasing it by, let's say, an inch, a total, so half inch on either side, that also changes how the modular kind of fin can or modular motor mount, if we decide to do that, will be implemented. So I mean, it's an option.
Yeah,
At
yeah,
most,
it's yeah. That's why I feel like there's 2 sizes. Like
at
thermocouples could
most, the
be.
thermal
Go ahead, V, my bad.
You're
You muted
good.
yourself.
I was just saying that at most they'd be like 4 millimeters. So we'd have a total addition of 8 millimeters per side. You know, if we do 4 of them, for example, it's 12 millimeters, which is about 1.2 centimeters, which is like less than half an inch total. Because a half an inch would be was it? It's 2.5 divided by 2 would be half an inch.
All right. Anything else before I stop the recording?
I think it would be pretty cool to have pressure sensors on the bulkheads so recovery knows exactly how much pressure is going to be generated by the black powder.
Are we not moving to CO2 tanks for 30K? Because I believe for
Well-
apogee at least we have to do with we can't use black powder at apogee.
What? I
Um,
haven't heard
Is that wrong?
Yeah,
Wait, was
I
that
mean,
was that wrong?
from the IREC rules, I didn't see that on there.
I believe one of the issues was, you know, like at 30,000 feet, black powder does not ignite properly. Like it's a very
Oh,
inconsistent ignition.
okay, yeah, you're yeah, you're kind of right about that, but that's not like a rule that we have to use CO2 canisters.
Yeah,
You
I
still
understand we have
can
to use
use
CO2.
black powder, but it's
Okay.
just you have to be more you have to be more careful about the way you light the black powder.
Okay, I
But
guess that
I
was
was
yeah
just
more my
saying,
question, if we were doing that or not.
yeah, well, what I was saying is, in case, well, regardless of what system we use, I think it would be pretty cool to know the pressure generated by whatever recovery system we use, so we can compare it to our test.
Yeah, we can definitely do that. Those pressure sensors, we can definitely implement them onto the bulkhead. Do like ground testing too, like we did last semester, with some improvised systems, maybe more pressure sensors, so we can validate their own data. You know, yeah, that'd be cool to execute.
Another thing that
Yeah,
was suggested by Eric when we met with him a while back was seeing if there's any way to add like pilot static tubes to the outside length of the rocket, so you can see where the flow separation happens. So there's air's flowing over the rocket from the nose cone down. There is a point though where there's a drastic drop in pressure, and that's because the flow separates from the rocket and becomes like turbulent and all that stuff. So finding out where that point is can be really useful, because below that point you wouldn't really need to have a consistent length or diameter of rocket. So you can literally just have a skeleton or like a motor underneath that with no like anything. So I know Oberon had a smaller diameter motor underneath or like inside the airframe, which was 6 inches. Technically speaking, if that flow separates somewhere midway in the upper airframe, the lower airframe could have just been like the motor's diameter, and it would have been exactly the same flow characteristic. Not exactly the same, but I assume pretty similar in the flow characteristics. So
What did you say at the start? That is used to measure that exactly? Sorry, I didn't.
so pilot static tubes.
Okay.
Have you heard of those?
No, not at all. I'm definitely gonna have
So
to look them up.
essentially, it's a little tube that has a hole on the leading face and a hole like on the side face. And so as air flows across it, air will go into the leading hole, which will cause an increase in pressure just because air is being forced into that hole. And there's also a hole on the side of the sensor or the probe, I guess. And so that measures the, I guess, the static pressure like in the environment. And so the difference in those pressures tells you like the what's it called? I don't really remember, but the difference to those pressures is useful because it tells you kind of like how the flow is going. If they're the same, then it you have you don't really have flow, and if they're drastically different, then you can measure like the velocity of the flow and a lot of different stuff based off of that.
I kind of get it. Okay. Yeah, it makes sense. At least the flow part. I'll definitely have to look it up and take a look at it. But I don't know how that implementation of it that would go down if structures and other people may need to get involved with that for sure.
Mhm.
All right. Well, I'm gonna stop the recording right now.